Hey everyone, myself Rishabh, and today I'm going to present on the topic the father of supercomputing. These presentations are part of our third internal assessments, and I'm giving this presentation under Dr. Vivek Srivastav sir. Now let's get started with the topic. Seymour Cray, also referred to as the father of supercomputing, his contributions laid the foundation of what we know as supercomputers today. Now, supercomputing is a fluid term. It changes time to time, so we cannot coin a specification and call it a supercomputer. Why is that? Because it is measured in flops or floating point operations per second. At that time, the specifications were different. As of today, what we know supercomputers, they can perform millions and billions of floating point operations per second. But we have much advanced technology now depending on the state of the art of the technology. At that time, he outperformed every competitor in the market. That's why he is famous for the term, the father of supercomputing. Now, let's get started. I have made an outline for this presentation. Here, I start with his early life and then his visions and belief, his life's work, and where did he fail exactly, and his final works. After that, Cray's contribution to modern supercomputing as what we know today. After that, use of Cray's vision and principles are used in cloud computing. So we are going to take a look at that also. After that, I'm going to conclude this presentation. I have included 10 MCQs at the end of the presentation. Now talking about his early life, Seymour Cray, he was born in September 30th, 1925 in Shippeba Falls, Wisconsin. Cray developed an early interest in electronics and engineering. There's a story that goes about Cray that when he was only 10 years old, he made a machine that converted punching tape into Morse codes. Now, this is fascinating considering he made that out of a erector set. Erector sets, if you don't know, are toys made for children that consist of metal pieces that they can put together and make different toys with. Now, Cray used this contraption to build a machine, and this made his father realize that he was quite the genius. His father was also a civil engineer who supported him in every way possible. His ambitions for computers and electronics was visible to his father. After that, he was deployed in World War II as a radio operator in US Army, where he gained valuable technical experience that would later influence his work. After that, he gained his degree from University of Minnesota, where he earned a degree in electrical engineering in 1950. His very first works consist of working in ERA, Electrical Research Engineering Research Association. Cray began his career at Engineering Research Association, where he contributed to the development of some of the first electronic computers. After that, he, with a friend, laid the foundation to a company called CDC, which we will later see in this presentation. Now, let's talk about his visions and beliefs. Cray also supported the square law, which states that if the size or the amount that you are buying the computer for doubles, the power it delivers to you should quadruple. Means that if the size of a computer is increasing twice, the power or the computational capacity it offers should quadruple. This is also called the square law. Other than that, there was one thing that he was very keen on, which is heat reducing heat. He wanted his machines to dissipate as little heat as possible. He also was quite bent on reducing the size of supercomputers and making it accessible for the public. He was so obsessed with the idea of making the fastest computer at that time. Now, let's see what he did with his life, what his life works are. Now, Cray, as we have seen in early life, that he was deployed in army also, and then he worked at ERA. After that, with a friend, he opened a company called Control Data Corporation, also known as CDC. His most notable work with the CDC Corporation was uh, Cray series of computers. He named them sorry, it was not Cray series, it was CDC, either 3000 series or 6000 series. Very first known supercomputer is Cray 6600. which, as we see today, marked the world's first true supercomputer. Released in 1964, it had an innovative architecture with a single powerful CPU and 10 small peripheral processors. Now, Cray actually supported the idea of one behemoth processor, one most powerful processor to do all the tasks with. But since he was working at CDC at the time, and marketing managers and different fundings of the company were not given to him, so that he could support his idea of making a supercomputer with just one or two powerful processors. He was skeptical about the idea of parallel processing. He wanted to process big chunks of data at once, other than breaking that data in smaller parts and then computing them separately. Now, later he realized that he was wrong, because in the late 1970s, his idea was being challenged by the competitors. Now, let's get back to our CDC 6600. This supercomputer was actually sold for $8.8 million to a organization. It was a government organization that monitored weather and needed a supercomputer to make complex calculations so that they can predict the weather beforehand. Actually, close to 80 units were sold of CDC 6600, which was a huge success at that time, since big government organizations, such as organization that needed it for space operations and stuff like that. So the company was quite happy with the product, since it was such a financial success. Cray later released some more series of supercomputers while working at the CDC. Now let's see its architectural designs. His architectural designs were so different that any competitor in the market had no idea about the architecture that their computers were working on. Such as we see a single powerful CPU and 10 peripherals to support them. Now, let's dig deeper into the CDC 6600. Now, the design focus was actually to reduce the size and the heat dissipation. As we know, Cray was so bent upon this idea, milestone in supercomputing. CDC 6600 was first true supercomputer at that time, and everyone was keen to buy it. Every organization wanted to have it. Be it the problem of imprecise interrupts. Actually, Crace helped to solve the problem of imprecise interrupts, which IBM was also working upon at that time, and he actually beat them to it. Imprecise interrupts occur in highly complex pipeline processors, where you cannot track down the exact state of a process before changing it. So, wherever bottlenecks were happening, and it was challenging to pinpoint what instruction caused the error or the slowdown in processes. So, this problem of imprecise interrupts was solved by Seymour Cray. He also revolutionized supercomputing in many ways, because at that time different chips were being used. So he was using gallium arsenide's chipsets, which were costly, but they were providing some efficiency at the time. Later, silicon became so cheap that his idea failed, but he was known for thinking outside the box. Single processor preference. As I told you before, Cray's skepticism about parallel processing and having small processors churning out small data operations was not his idea. He he gave an analogy that two strong oxen or two strong bulls are more powerful or better than 124 chickens. If you want to plow a field, what would you choose? Two strong oxen or 1024 chickens? So that is his way of telling us his idea, that he supports that he wanted two powerful or even a single powerful processing unit in his machine, so that no resources are being wasted in breaking down the complex calculations and complex data sets. Now, after that, designing for performance. Craze focus on designing for raw computational power and speed rather than relying on parallel processing set the direction for his work. Now, the problem with parallel processing is you need to see the big calculation first as a whole unit, and then you divide it in parts, which also takes computers resources. Seymour wanted it to happen in one singular go. This is his two strong oxens versus 1024 chickens analogy. He preferred single powerful processors over multiple smaller ones, using an analogy two strong oxen versus 1024 chickens to argue that one powerful processor could handle complex tasks better than many weaker ones. And this was true at that time also. Later, parallel processing and pipelinings became so efficient and so powerful that they defied this idea. And in the last supercomputers he was working on, it was Cray 4, I believe, he also tried to implement this idea of parallel processing, which we will later see. Now, he then founded his own company, Cray Research. Now, the problem with CDC was his ambition was to make the fastest computers at that time, but the management team at CDC wanted him to create computers like CDC 6600 that give us the market for finance and business people. Cray did not wanted that. Cray wanted to build the fastest computer at that time. He was a man with a vision, a man with a mission actually. So he couldn't stand the management team there in the CDC corporation. So he left and opened Cray Research. I think he was fund. He had 2500 25 $250,000 at that time, I believe. I read in an online article. And then he got funding from Wall Street also, uh, because uh, because of his because of his fame, all the fame that he gained from Cray 6600, CDC 6600. Those supercomputers were quite successful. That's why everybody in the finance world knew him. Now, after leaving CDC, Cray could freely build new computers as the way he intended. But these new operations were quite costly. That's why the funding things come from. Now, he aimed to push the boundaries of supercomputing even further. Although CDC 6600 and other series there, like such as CDC 3000 series, were also perfect and very fast from the competitors at the time. But Cray was a free spirit, as we can see. So he left the company because he did not like management wanting him to create the same set of computers for general public. He had the idea of creating something most powerful for the time being. Now, in the process of advancing supercomputing, to make another leap, he was always seeking for different things, such as I gave you the example of he transistor logic TTL was being used before, and he changed it to gallium arsenide chipsets, GAAS transistors, I believe they are called. Now, the thing is with gallium arsenide, it was a new technology for the time, so it was efficient for his work, but quite costly for the company. And since it was still under experiment, so many prototypes failed also. This shows his visionary leaderships that he can do things on his own. Cray's founding of Cray Research demonstrated his unwavering commitments to pushing the boundaries of what was possible in supercomputing. Now, if he had not left CDC, he would have been making commercial computers and for the company, because a company has a board of directors that select what is best for their company. Revenue wise, funding wise, everything is maintained by them. So his visionary leadership shaped a way for a new company, which was Cray Research. And after 4 or 5 years of research and development, he came up with his own series of supercomputers that he named after himself, known as Craven. Now, Craven was such a huge success that we will see landmark achievement. The Craven became a landmark in computing due to its exceptional speed and innovative design, making it one of the most influential supercomputers in history. As I was talking, because he had a aim, he had a mission. He opened his own company and succeeded also. It's quite rare that people can do that. Now, technological leap. Why was Craven so influential? Why was it different from the other computers such as CDC and other manufacturers such as IBM was making? The Cray one represented a significant advancement in the supercomputing, setting new standards for performance and ushering in a new era of high performance computing. Now, Cray's unique design approach focused on simplicity and efficiency. He wanted to reduce the size and reduce the heat dissipation. He was always in constant search for coolants for his computers. He also used submergent cooling, where he would submerge the whole device under a coolant that would not sort the electronical pieces together. Now, this thing helped him to keep the temperature low, and when the temperature of a device is low, the efficiency always increases. As we see today in our laptops and our desktop computers, we have a dedicated fan for its cooling. We have several thermal paste and different sort of computers have new technologies such as vapor chambers. So at that time this idea was not introduced of vapor chambers and you know water cooling. So that's why the term submergent cooling comes from, where it would submerge the whole thing into a non-conducting liquid that would not harm the computers and also keep them cool. So these are all the design innovations that Cray made throughout his career. Now, after that, let's before we talk about where did it go wrong, actually we need to understand that after Cray 1's huge success, Cray 2 was also released, which was a little less powerful as people would expect from something that Cray would make, Seymour Cray would make, because at that time he was so popular that because of his influence, people were expecting better outcomes from him. After that, Cray 3 failed miserably because, as we talked earlier, supercomputing is a fluid term. It can change anytime. That that exactly hit him, and there were several more reasons for Cray 3 to fail, which we will talk about in this. So the Cray 3 project, which Seymour Cray developed in the early 1990s, faced significant challenges, ultimately leading to its failure. Now, one key reason was changing landscape of supercomputing, because again it is a fluid term. What was once considered state of the art no longer met evolving needs as supercomputer goals and technologies advanced. So, what he was working on for so long, what he had planned that his line of computers, Cray 1, Cray 2, or Cray 3 would progress, let's say the surrounding technology evolved much quicker and much better than his work. So, Cray 3 struggled and struggled a lot. Later, it was also discontinued. Now, let's talk about some of the things that resulted in the failure of Cray 3. Outdated design philosophy. By the time Cray 3 was under development, supercomputing had moved towards parallel processing, as I told you, because IBM lost to CDC because they were working on a different architecture. And CDC won because Seymour Cray was on their side and he believed on a behemoth single processing unit. And later, parallel processing became efficient and simply outperformed Cray's design. So that's why it is called the changing landscape of supercomputing. That's why I'm repeating it again so you guys can understand that supercomputing is a fluid term. Now, let's talk about parallel processing, how it changed the landscape of supercomputing at that time, mid 1990s. Now, whenever multiple processors worked on tasks simultaneously to achieve higher performance, Cray, however, was still focused on maximizing the speed of a single powerful processor. Now, uh, which had been effective in the CDC 6600 and the Cray 1, Cray 2, and other prototypes that he made in his laboratory. His laboratory was also placed in Wisconsin, I guess. He is also known as the Wizard of the Chippewa Falls, something like that. Now, let's get back to our uh, failure of Cray 3, why Cray 3 failed. Now, it had some technical challenges also with his gas transistors, gallium arsenide. They chose gallium arsenide for the Cray 3 to improve speed and reduce heat, as it could operate at higher frequencies than silicon. He actually reached close to 1 gigahertz processor frequency, which was quite high at that time. but it kept failing because it was not that efficient as he wanted it to be. Now, gas was also difficult to work with and it was also expensive. The more prototypes he made, the more money company lost, which later caused the Cray research to fail, and at the end they had to file for Chapter 11 bankruptcy. So that was quite a setback in his life, but he still wanted to create something. He was so bent upon that idea that he again opened an organization known as SRC Computers. uh, Now, before that, let's talk about the last thing, changing market demands. Now, since he had seen few successes before also, such as CDC 6600, that unit sold to closely to 80 units, I believe, and so much financial help was given to the company because of that. All the investors wanted to put their money in this new idea of supercomputers. Now, but as the idea became old and many competitors entered the market, it was hard for him to make revenue out of his computers. And simply Cray 3 couldn't perform that well, and no funding was left to give it. At the end, the company filed for bankruptcy. So, these changing market demands, supercomputing applications in the 1990s had shifted focus towards data intensive tasks, which again were done by the parallel processors, which Cray did not include in his supercomputers. So, he simply failed because his supercomputers were not needed by an organization that would process a single chunk of big chunk of data at once with his powerful line of processors. Now, in areas like climate modeling, modular dynamics, and data analytics, Cray's focus on pure computational speed did not address these emerging demands. So, let's say parallel processing was something that let Cray down. But learning from his mistake, he took that idea in and started to build his own set of computers which included the idea of parallel processing known as Cray 4, which he later made in his new company, SRC Computers, yet again. Now, the thing is, he never failed or he never accepted his defeat. He started with SRC Computers, founded by Seymour Cray. After leaving Cray Research because it filed for bankruptcy, now these emerging challenges, by these challenges they mean parallel processing, SRC introduced the concept of reconfigurable computing, which allowed for the adaptation of hardware to specific tasks. Means under intensive load, a single chunk of data could be processed on user's choice. He could either break it down to smaller pieces and then process it, or he had also the choice of processing it as a single unit. This is what they call the reconfigurable computing. This approach aimed to address the increasing demand for data intensive tasks and networked systems, providing a more flexible and scalable solution for evolving market. Now, at the time of his uh, opening the new company, as he was just coming to the breakthrough with Cray 4. Cray 4 would have helped him with his career, but he met with a tragic car accident and lost his life there. So, the father of supercomputing lost his life to a car accident. Now, tech enthusiasts like me really feel that this was a major downfall for all the concepts that he could have imagined, supercomputing in itself. Now, at the time of his death in 1996, Seymour Cray was working on Cray 3 as well as Cray 4 projects with a specific focus on Cray 4 because he included new technologies and new ideas he had in Cray 4. This project represented his computing ambition to push the boundaries of supercomputing with faster and more compact machines. Cray 3, which used gallium arsenide technology to improve speed, had faced technical and financial challenges which we've seen before. Now, following setbacks with the Cray 3, Seymour Cray began the Cray 4 project under Cray Computer Corporation. The Cray 4 was intended to be even more advanced, using similar technology but aiming for a smaller and faster design. Now, with this, he also intended to make this cheaper so that finally the local public or the general public could have access to it. But before his dreams could come true, he was taken away from humanity. So, unfortunately, financial difficulties and technical issues persisted. So, all the research and development was taking quite long. So, Cray 4 was delayed also. And then later he was no more to complete this idea. Despite these challenges, Cray's commitment to innovative computing continued until his passing. And let's move forward. Now, Cray's contribution to modern supercomputing. What we see today, Seymour Cray's contribution to modern supercomputing laid foundational principles and techniques that continue to shape the field. Here are some key ways his works influenced modern supercomputing. First of all was pioneering supercomputing concept. He founded that word basically because he was close to he was one of the first engineers that worked on computers at that time because after World War not many companies were focusing on these things. So introduced the CDC 6600, the first coin term for supercomputers in 1964. Now, after that, innovative vector processing, where enabling efficient handling of large data sets with the help of vector mathematics, a very big milestone for modern supercomputing applications. After that, modular and efficient design. Now, this modular and efficient idea comes from his idea of making his computer smaller and make them dissipate less heat. Now, less heating would already increase the efficiency by 10 to 20%. And other than that, the processors are always being worked upon so that they can perform much better than last generations. Advanced cooling solutions. He addressed issues and he took them very seriously. That's why he was in constant search of better coolants for his devices. Parallel processing foundations. Although Cray 3 failed because of lack of parallel processing and use of gallium arsenide transistor, but later he realized and included that idea. This shows how adaptive he was, how adaptive, and he did not accepted his defeat there. Included the idea and started making a new computer out of it. How high performance networking inspiration. As Cray 4 was working on reconfigurable computers, they also included the idea of high performance network. And then legacy in software optimization. The name Cray itself will, as you guys have seen this presentation now, so now I believe you guys will also remember him. So emphasized optimized software to fully utilize the power of hardware, because the problem with even in today's standards, some softwares are not well fully optimized so that they can take advantage of full capacity of the computer they are running on. Now this is largely an issue because there are uh, so many manufacturers making different processors, different architectures, so that take different instruction sets. So this is still a problem, but he wanted it to get solved. And some companies that integrate it quite well, they are faster, they are more efficient, and they utilize 100%. Now utilizing 100% of CPU is not possible, but close to 100% of the CPU's efficiency. Now after that, his contribution in supercomputing basically helped also developed the idea of cloud computing, which was modular, which was because of all this high performance networking accessible from anywhere in the world. So we also believe that use of Cray's vision and principle could be applied to cloud computing, and then later it would help as what we know cloud computing today, such as heat management efficiency of all the servers, all the data centers is required. Cray also believed that their computers should not dissipate heat. They should not waste electrical energy into heat energy. Based cooling techniques inspire modern liquid cooling and energy efficient data centers, reducing costs and enhancing performance. And modular design, such as we see in server racks, there are different racks that you can attach or detach. As a user, if you want, you can go to data centers and give them your own server rack with his own CPU or whatever software you are trying to make. HPC, high performance computing in cloud. Now, this idea comes from that supercomputing approach. Cloud providers now offer high performance computing on demand. Uh, Crave wanted the general public, the local public, to have access to these computers, which is now possible with the help of distribution in cloud. Because anyone without a powerful machine or a dumb terminal can connect to a cloud provider service and use such servers to uh, calculate complex operation. Means in The idea remains the same. He wanted general public to has access to high performance computing, and cloud is making that happen, which is quite good for the all the research purposes and all the organizations that do not have their own hardware and infrastructure. After that, parallel and distributed systems, now parallel processing and things like that laid the foundation to, backups and backup servers, such as you can clone your server, and then if a bottleneck happens, if a failure happens, you can start your other server. Cray's parallel processing foundation underpin distributed computing in cloud environments, enabling scalable, reliable performance across vast applications. Scaling is also used vastly in cloud computing as today. After that, let's conclude this presentation. Now, me personally, I am uh, so much influenced by technology. At the age of like 12, I saw my first uh, smartphone. It was a ZTE Blade. It was built by a French company, which was Alcatel One Touch, and it was the coolest thing I saw at that time. And I still am very enthusiastic in these matters. Anything related to new technology, to even older technical approaches, they fascinate me quite a lot. So this is remarkable how that man's vision laid the foundation for a computing system we rely on today. His innovations have not only changed the landscape of computing, but have also inspired countless individuals like myself. If you are facing a problem, you would try to solve it through computers and computing approaches, and it's actually a good thing. As we move forward in our own technological journeys, sorry, as we move forward in our own technological journeys, let us remember the giants like Seymour Cray upon whose shoulders we stand. It's our responsibility to continue pushing the boundaries of what's possible and what's not. And we should always remember guys like him who contributed so much to the architectures and performance of CPUs, because things like these phones that we use today are more powerful than Craven. But at that time, it was almost impossible to build something like that. So, yeah, now I would like to conclude this presentation. Thank you for your precious time. I have added some multiple choice questions so you can get the idea of what you learned and what you did not understand. You can watch that again. Now, let's look at these questions that can test your knowledge about Seymour Cray's contribution to the field of computing and impact of his innovations. Now, let's see these MCQ. Now, question number one first comes at, what was Seymour Cray known for pioneering? I think most of you will get this one. It's personal computers, supercomputers, or option C, embedded systems or mobile devices. As we are talking about supercomputers for this whole presentation, I think you all know the answer is option B. Yeah. After that, which of the following was the first true supercomputer designed by Seymour Cray? CDC 6600 or Cray 1 or Cray XMP or CDC 7000 series? The answer is option A. CDC 6600 was first true supercomputer at that time, which was built at 1964. Answer A. Question number three for you is, what innovative technology did Cray implement in his machines to enhance performance? Microprocessors, vector processing, quantum computing, or artificial intelligence? Now, some of these terms are actually coined as of today. So, the correct answer is vector processing, which is option B. If you are watching this video, please attempt these questions in comments first, then look at the answers. You can pause at the question and then think what is the correct answer. Now let's see. Question number four. During which war did Seymour Cray serve as a radio operator? Option A, World War One. Option B, World War Two. Option C, Korean War. Or option D, the Vietnam War. So the correct answer for this one is World War Second. After that, question number fifth is, which design principle did Cray advocate for in his supercomputers? Complexity over simplicity. Option B is modularity and efficiency. Option C is size over functionality. And option D is high cost for high performance. Now, option D, just right off the bat, is wrong because why would you want to pay for high performance? His own life work was based on making the technology faster and cheaper. So, option B comes as the right answer, which is modularity and efficiency, which he worked for his whole life. Answer B. After that, question number 6 is what notable cooling techniques did Cray use to manage heat in his supercomputers? Now, if you watch this presentation with attention, I have said that twice in this presentation actually. First is air cooling, second is liquid nitrogen cooling, third is gel cooling, and fourth is liquid immersion cooling. Yeah, fourth one, liquid immersion cooling, where the whole machine is submerged under a non-conducting fluid. So the correct answer is answer number D. Option number D actually. Now question number 7th will be which of the following best describes the square law as related to Cray's work? Performance increases linearly with size. Cooling efficiency increases with size. Performance increases by the square of the size increase, or cost decreases with size increase. Now, the correct answer is performance increases by the square of the size increase. If you're actually performance option A is selected because option A is also correct. Sorry for my mistake there. Performance increases linearly with size means as it doubles, as the size of something doubles, the performance we get out of it is in the squares. I will look into the options again. If I have made such mistake, I will mention it in the comments. As for now, let's consider answer A as our option. Now, question number 8. What was the primary goal of Seymour Cray's innovations in computing? To create smaller devices, to develop user-friendly interfaces, or to enhance computational power and efficiency, or to focus on the software development? Now, he was mostly bent upon the idea to enhance computational power and efficiency. So, our correct answer is option C. Question number 9 is why did Seymour Cray leave Control Data Corporation or CDC in the 1970s to pursue a career in academia, to focus on personal computing, to establish his own company, Cray Research, or to work on government defense project? Option C here is the right answer, guys. To establish his own company, Cray Research, because he was not happy with the management forcing him to make regular consumer targeted products. He was made to do something big. Make He was bent upon the idea of making a supercomputer, making him a man with a mission and man with a vision. So option C, to establish his own company, Cray Research, which later founded Cray 1, Cray 2, and Cray series of computers, supercomputers actually. The last question is why did Cray 3 supercomputer ultimately fail in the market? It was designed with outdated technology. It focused solely on personal computing. Option C is it faced delays in development and shifting market demands. And option D is it was too affordable for the supercomputer market. Here, option A is the right answer. It actually suffered what we call outdated technology, lack of parallel processing, and use of gallium arsenide transistors really affected him. Now, this is the end of the presentation here. Thank you guys for your precious time. Seymour Cray also worked in, composite semiconductor, metal oxide semiconductors, CMOS, as we know today. Every motherboard that we see has a little CMOS battery inside that keeps track of the date and time. So that was also contributed by Seymour Cray. And what a guy. As a technology enthusiast myself, I admire him so much. I got to know him about from my professor actually, uh, Mr. Vivek Srivastav. He teaches us cloud computing. He mentioned about him in a lecture once, and I was actually influenced that a guy almost what almost 60 years before had this idea that he converted into a reality, and now we can use these computers. My machine solely has more power than his supercomputer that would take up a whole room. Technology can be quite fascinating, and with people like him, it is actually, I'm very lucky that I live in such a time frame where I can witness such things. Thank you. This is Rishabh signing off. Thanks for watching. See you in the next one.